So let's try to draw this Boolean expression. There's a question. Draw the circuit diagram of the Boolean expression below. A equals to x, y, z, or with x bar, y bar, z bar. Okay. So before you start drawing, let's analyze the expression for a moment to answer ourselves some basic questions. Okay. How many inputs are there? And so you got this thing here represents the input. Count how many different alphabets are there. X, Y, Z. These are also X, Y, Z, but it's being transformed to X bar, Y bar, Z bar. But so there's 3 different alphabets, so there is 3 inputs. Okay. And how many output? Okay, there's only one expression you're supposed to draw, so therefore it is one output. And the output is represented by the alphabet A. So this is their output. Okay. So before we start drawing, okay, so you know there's 3 inputs, so let's draw that, put that. You got X, Y, Z. This is your input. Output, you draw it on the right side. You got A on the right side. That is your output. So you remind yourself at the end of it, after drawing through all the different logic gates, you should arrive at finally the output A. So before you start drawing, ask yourself, okay, look at this expression. Okay, what on a high level, what are you trying to do? Okay, we're trying to perform an OR operation of 2 expressions, 2 composite expressions here. Something or with something. So bear that in mind. So you tell yourself, okay, eventually near the end of the last stage of the drawing, last stage of the diagram, you should have something or with something. Therefore, it leads you to think that, okay, I should draw a diagram, something like that, near the end of the stage of my diagram. Something or with something. So this is a OR gate. And then you start to, with this in mind, then you can start to try to draw the different expression individually. Okay. And so let's work on the first expression first. The first expression. The first part of the expression is this. So let's start working on this first. We want to AND X, Y, Z together. Okay. So something X, Y, Z. You look at this. This is a AND gate. So you draw an AND gate. Then you AND everything together. So that is my X, Y, Z as expected. So X, Y, Z. So you have done for one part of the expression. Great. And you can feed that to the eventual stage, the next stage. Okay. And let's work on this part of the expression now. Now you want to actually AND X bar, Y bar, and Z bar together. Now, so you want to do a AND. Before you could do a AND, you need to individually invert the signal Y, invert the signal X, and invert the signal Z. Okay, individually invert them, then you perform a AND operation, right, to the individual signal. So that is what we are trying to do. Let's do the individual inversion first. Okay, produce this signal first. X bar, Y bar, Z bar. So from X, how do you derive a X bar? Simple. So what you do is you use an inverter, right? So you tap from your X. Okay, going through an inverter, that becomes your X bar. Likewise, your Y bar, how do you derive a Y bar? You need an inverter. Okay, and you tap from your Y. Where is my Y? Yeah, this is my Y. Go through that. Okay, so that is my Y bar. And then you got a Z. Okay, you need an inverter to transform your Z to Z bar. Yeah, so this is my Z bar. Okay, clean it up. Okay, that is my Z bar. Z bar. That is my Y bar. Okay, and then once you have the individual signal, x bar, y bar, z bar, then we are ready to AND them together as per this expression. Something times something times something is AND gate. Okay, so you AND them together. Okay, great. And you have the, your signal x bar, y bar, z bar. So you are ready now to OR it together. Yep, you're supposed to do a OR with this signal. This one is supposed to be ORed together using an OR gate, and therefore you have your A. Yeah, and you can always after doing all this thing, you do a test. You just kind of work backwards to see have you really indeed got the right diagram. What you could do is kind of walk through the maze. Remember the method? We actually walk through the maze to ask ourselves what was our expression. So by all means, do that to do yourself a favor to verify if you are correct. So you could walk through the maze. Let's verify that. You could just walk through. Imagine you're a mouse and you kind of walk through the obstacle. X, walk through this. This is the AND gate, but you need to have all the inputs ready. And this is your X, this is your Y, this is your Z. So therefore, walking through an AND gate, that is your X, Y, Z. Okay. You walk through that. Okay. You want to transform, but it's an OR gate. We cannot transform it because you don't have what is here. So you work backwards. Oh, okay. AND gate. You don't have the information here. You work backwards. What is my inputs here? This is my trace back. This is my X. X go through an inverter becomes X bar. Okay, Y go through an inverter becomes Y bar. Z go through an inverter becomes Z bar. And then you go through an AND gate. AND gate means you AND them individually. Yeah, all the different inputs, just AND them together, multiply them together, so to speak. Okay, and then going through here, it is you're ready to transform again, and then this is your OR gate. So something OR with something. So X, Y, Z, OR with X bar, Y bar, Z bar, and that is exactly what you are looking for. A equals to X, Y, Z plus X bar, Y bar, Z bar. So you verify that yes, that is correct. So thank you. I hope you learned something from it.